Hello everyone, welcome back. You may notice that I've cheated a little by jumping to the AIME II instead of finishing the last 5 questions of the AIME I. Part of the reason is because I wanted to release this first, and we will see if we have time to release the video for the last 5 questions of the AIME. However, I'm just working under the not too unreasonable assumption that anyone who is able to actually do a significant number of the last 5 questions probably has already qualified for the AIME last year, in which case you would already have seen those questions. So I'm going to go on that basis and therefore prioritize going over the first 10 questions of the AIME II, since the contest is drawing near in a matter of less than 2 weeks. Okay, so we will do a very quick review of the first 5 questions from the AIME II instead. And if we have time before the AIME, we will come back around to look at those final 5 questions of both of these papers. Alright, so without further ado, let's jump in. The first question talks about an arithmetic sequence. And the greatest number of apples growing on any of the 6 trees is double the least number of apples growing on any of the 6 trees. So it basically goes x, 2x, and then 4 spaces in between. 4 spaces in between means that it's just 1/5, or maybe I can just write it as 1.2, 1.4, 1.6, and 1.8x. And this is supposed to sum to 990. So 9x equals to 990, and the greatest number of apples growing on any of the 6 trees, 2x equals to 220. This is a sort of a mark donation by AIME standards, so let's move on. Second question. Palindrome is a number that reads the same forward and backward. Find the greatest integer less than 10, less than 1000. That is a palindrome both when written in base 10 and when written in base 8, such as 292 equals to 444 in base 8. The good news is that once you see 292, your answer is bigger than that, so it must be a 3-digit number. 3-digit in the sense of base 10 3-digit number. In base 8, it could be 3 or 4-digit. Right? The reason why we know it can be 3 or 4-digit is, let's say if I have something like 999, 999 is more than 8 cubed. So in base 8, it would be having a 4th digit. In fact, anything that is more than 8 cubed in base 8 would have at least 4 digits. So once we know that is the case, we can assume that if we're looking for the biggest one, I would like to think it's a 4-digit in base 8 and a 3-digit in base 10. So let's try to understand what that would actually entail. So 3-digit in base 10 means ABA base 10, and then CDDC in base 8. This is 101A plus 10B. This would be, okay, so C and C is, this is 8 cubed, 512C plus 64D plus another 8D plus C is 513C plus 72D. Looks a bit confusing, but I can see a few things. One is that this is going to be quite big if I'm not careful. So C can at most be 1, right? Because if C is 2, you are exceeding the 3-digit quota here. So C must be 1. And I can just sort of test out the different cases of what D could be until it exceeds 999. So if D is equal to 0, which is allowed, I just get 513, which is okay, so this doesn't work because you need the, we're basically just checking whether it's a palindrome. Right? What am I doing? I don't need that. I just need to check whether this is a palindrome. Okay, so scrap that. 585 is a palindrome. and then after that I can just continue adding 72 and okay, 72. I don't think anything else is going to work, but hey, let's just do it to completion since there is only one or two more. Okay, and then the next one will be more than 1000, so I can ignore that, and it looks like 585 is actually the only palindrome in this list of 4-digit numbers in base 8. Anything else would be even smaller. So that would be my answer, 585. Don't be afraid to do some listing whenever you are handling anything that is to do with digits, because the meaning of digit is that, well, there is only 0, 1, 2, 3, 4 until usually 9. In base 8 it means up to 7. Either way it's quite limited, so don't be afraid to do some listing. Okay, question 3. This is a very nice special case because it's an isosceles right triangle, so I shall happily draw that. What can be too bad about an isosceles right triangle, right? So this is a right angle. P is somewhere inside such that PAB equals to PBC equals to PCA. I know there's a name for this point. I can't remember what it is, but I suppose it's okay because it should be something that I don't need if I'm working in isosceles right triangles. So let me just eyeball something where it would be conceivably true, something like this. Where PAB, PBC, and PCA are supposed to be equal to each other. This is 10. I can call this length x, x, and x square root 2. This is 45 degrees minus whatever that is, so I can call this theta, 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 45 minus theta. So actually this is 90 minus theta. Oh, this is a right angle. Okay, so as we can see, sometimes just labeling everything in a slightly confused fashion can be good, right? This is 135 and 135, and this is, I've run out of space, this is 45 minus theta. Great. So if that is a right angle, then this is 10, this is x, this is square root of x squared minus 100. I am thinking that I can just either bash this down with some trigo, or am I going to have anything better than that? Oh no, I don't need to bash that down with trigo because I have similar triangles. Oh, that's nice. Okay, so triangle APB is similar to triangle BPC, and the scale, since AB to BC is 1 to root 2, that just means that AP to PB is 1 to root 2, and BP to PC is also 1 to root 2. Oh, that's great. So that means that BP is 10 root 2, CP is 20. And what do you know? The right angled thing that we had just now just gives you x is equal to root 10 squared plus 20 squared equals to root 500, and your area is 250. Now, I always like these kinds of questions at an early stage because it is the kind of thing that can be done in quite a lot of different ways. Nonetheless, when you have something that sounds special, it's probably special. So even though it can be done in a lot of ways, meaning that in the worst case scenario we can bash a lot, try to see what nice feature you can identify that would preferably not require you to make a huge mess. Fourth question. Okay, so let x, y, z be real numbers satisfying this system of equations. Sorry if earlier on the top part of the question is a bit cut off. I realized that that may have been the case. Anyway, so we have just got this system of very symmetric looking equations. We are asked basically for all possible values of x and to do, well, some answer extraction from there. X, y, z are real numbers. X, y, z are not actually integers. So I don't want to do some sort of factorization and checking factors thing. I would just look at this and say I can subtract any pair of them. Because that would give me a 0. X minus z, y minus 4 equals to 0. And by symmetry, you also get z minus y, x minus 4 equals to 0 if we just subtract them in all the other pairs. Okay, so now I realize that all of these, we need to not get tangled up between the cases. So since it's focusing on x, let's make x the main character. Now, one way that this could go is x equals to 4. And if x equals to 4, I mean, I could just check that it is in fact okay. So if x equals to 4, this would be satisfied. And I just need, well, in fact, y minus 4, z minus 4 to be equal to 0. So one other thing is equal to 0. So let's just make sure that, again, there is such a possibility. Let's say if y equals to 4, then it would look like I've got to make sure that 16 plus 4z is 60. And z would be 11. That's okay, right? So 4, 4, 11 is certainly fine because then all of them will look like 4 times 4 plus 4 times 11. So 4, 4, 11 and its different permutations would all work, and in fact that gives me a bonus value of, well, x could be 11 as well. So let's in fact rephrase this to say if any of them is is 4, and then without log x equals to 4, and then x equals to 4 will make one of the other ones also 4, and the third thing become 11. So that's the first scenario. The second scenario is that none of them are 4. So otherwise what happens? Otherwise it means that x, y and z all have to be equal, right? All of these are 0. And I can now just put that into the, what would be 3 copies of the same equation. And x squared plus 4x equals to 60 surely can be, you know what? I don't think that, okay, that gives 2 different solutions. I was just thinking whether it overlaps with just now, but it actually does not. So x equals to 6 or negative 10. So you get a very interesting assortment. You get 4, 11, 6 and minus 10, and your answer would be sum of squares. 16, 121, 36, 100 sums to 273. Yeah, so I think when I see something like this, I would always be more concerned about missing some cases. So if you're doing things symmetrically, just realize that you have to loop all your solutions around. So if let's say x equals to y equals to z, I didn't have to worry about looping them around. But when it was x equals to 4 and it turned out 4, 4, 11, I'll just quickly remind myself to loop things around, otherwise I may have missed out the 11 at the end. Alright, so finally, question 5. This is quite a short video, and this is also, in my opinion, quite a doable first 5 of an AIME. So finally, let S be the set of all positive rational numbers R such that when the two numbers R and 55 are written as fractions in lowest terms, the sum of the numerator and denominator of one fraction is the same as the sum of the numerator and denominator of the other fraction. Okay, so it means that A over B in lowest terms, if let's say this is R, 55R equals to, well, 55A over B is going to be simplified into lowest terms in such a way that causes them to be the same. Now I can only see that if it's simplified to lowest terms, it means that 55 has a common factor with B. So it either cancels off 5 or it cancels off 11. It can't have been cancelling off nothing because then the sum would not be the same. It can't have cancelled off 55 because then the sum would clearly be smaller. So this is something that I do not need to consider. Okay, so I can just check both cases. A plus B equals to 11A plus B over 5 means that 10A equals to 4B over 5 and A to B is 2 to 25. Now, every time when I write it as a ratio, because A and B are in lowest terms, so that literally means that R is 2 over 25. So I can do this again for the other one. And I expect something similar to show up. So 10B over 11 equals to 4A. A to B this time is going to be equal to 5 is to 22. So that's another one. Okay, so those are two values. Let's just add them up first and see what we get. 25 times 22 is 550. 44 plus 125 is 169. So that's 13 squared. So this is indeed in lowest terms. And our answer is 719. So this is a not too weird first 5 questions for AIME. I think compared to the AIME I, this is maybe a little bit easier and a little bit more conventional. So thanks for watching, and we'll be back with the next 5 questions really soon.